Hi folks, Chris McClure. This is our very last section and thus my very last recorded lecture with you guys. And we're going to finish up the semester by talking about properties of logarithms. Well, we've discussed logarithms last time. We defined a logarithm as the inverse of the exponential function. Okay, so here we go. We're going to work with properties of logarithms here. First of all, regardless of the base, the log of 1 is 0. And we could show that by saying, okay, let y be equal to log base a of 1. And that means that a to the y power is equal to 1 by definition of the logarithm. But you could write 1 as a to the 0 power. And because a to the y is equal to a to the 0, that means that the exponents y and 0 must be equal to each other. So therefore, since y was log base a of 1 and y is equal to 0, that means that log base a of 1 is equal to 0. When you can go through the same process here for part B to show that log base a of a, so you take the log of the base is always equal to 1. And so we can let y equal to log base a of a. That means a to the y is equal to a. But a is a to the 1 power. That means that the exponents y and 1 are equal to each other. Y is 1, but y was log base a of a. So we can conclude that log base a of a is equal to 1. So these are two important properties of logarithms, that log of 1 is 0 regardless of the base, and log of the base is equal to 1. So natural log of e is 1, log base 2 of 2 is 1, and log base 10 of 10 is 1. All right. And because of the fact that the exponential and the logarithm functions are inverses of each other, we can compose the one with the other and always get the input. So, f inverse of f of x is equal to x. A raised to the log base a of m is equal to m. Or log base a of a to the r power is equal to r, because log base a of a raised to the r power, that's going to be the same as r times log base a of a, which is 1. So r times 1 is r. So you have log base pi of pi cubed. Well, that's going to be 3. This whole thing is equal to 3 because of the composition of the log with the exponential. And 5 raised to the log base 5 of square root of 3 is square root of 3. Again, you're composing the exponential with the logarithm of square root of 3. Natural log of e to the 0.35t is just the same as 0.35t. Here are some important properties of logarithms that if you've taken the logarithm of some base of the product of two numbers, that's the same thing as the sum of the logarithms of those two numbers. The logarithm of the quotient of two numbers is going to be the same as the difference of the logarithms of those two numbers. And also that the logarithm of some number raised to a power is going to be that power times the logarithm. So let's just see how this goes. In fact, these are going to be extremely useful properties when you get to calculus, especially when you're evaluating limits. So let's see how this goes. Suppose that we've got the log base 2 of quantity x squared times cube root of x minus 1. We're going to assume that x is greater than 1. Otherwise, we'd be taking the log of some negative numbers, which is not allowed. All right, so look within here, within the argument here, we've got powers and products and stuff. So First of all, let's just write the log of the product of x squared times the cube root of x minus 1 as the sum of the logs of those two expressions, and then use another product that allows us to write log of the powers, the power times the log. Now, our next step, we're going to rewrite the cube root of x minus 1 as x minus 1 raised to the 1/3 power, and then use that property of the log of the power is equal to power times the log. So you notice that this exponent of 2 comes down to be a multiplier of the log of x. And likewise over here, this is power of 1/3 on the argument here is going to this 1/3 is going to come down to be a constant multiplier of the log of x minus 1. So this is a very handy property of logarithms. You can take the log of some complicated algebraic expression and be able to expand that expression out. Very useful for evaluating, various operations that you'll be doing in calculus, for example. Suppose that we've got log base 6 of x to the 4th over x squared plus 3 squared. Well, use properties of the logarithm first. Well, remember, the log of the quotient is going to be the difference of the logarithms. And then use that power property that says that the log of x to the 4th is 4 times the log of x, and that the log of x squared plus 3 is the same as 2 times the log of x squared plus 3. But let me just tell you right now, the log of x squared plus 3 is not the same as log of x squared plus the log of 3. You cannot roll it out like that, pretending that's a linear function. No, the log is not a linear operator. But a lot of students are under the impression, though, that if you have the log of the sum, that would be the same as the sum of the logs, and that's not true. The log of the product is the sum of the logs, but not the log of the sums. It's not the same as the log or sum of the logs. All right, so what about this one? Suppose that we got natural log of x cubed times square root of x minus 2 over x plus 1 squared. Again, use the property of products and quotients. That, first of all, we'll deal with the quotient piece first. That we'll write this as natural log of x cubed times square root of x minus 2 minus natural log of x plus 1. And then we can use the next property that will tell us that this logarithm right here is going to be the natural log of x cubed plus the natural log of square root of x minus 2, which we'll write as natural log of x minus 2 raised to the 1/2 power. Then just use that power property for these logarithms here that brings down those powers out in front as constant multipliers. And that's it. So we have expanded this logarithm using these properties of logs. And we can kind of go in the other direction. If you've got 3 times natural log of 2 plus natural log of x squared, we can combine these logs into one logarithmic expression by going in the opposite direction. First, 3 times natural log of 2. Well, you can bring this 3 multiplier up as a power on 2, like that. And then you have the sum of 2 logarithms. That will be the logarithm of the product of, 2 cubed is 8, so 8 times x squared. So natural log of 8x squared is the same thing as this guy right here, of the sum of these 2 logs. Let's take a look at the second example here. We got logarithms of the same base, so we should be able to combine these first using the power property that says that 1/2 times the log of 4 is going to be log of 4 to the 1/2, which is square root of 4, which is 2. And also 2 times the log of 5 is the log of 5 squared. And now go ahead and apply those powers, and then use the quotient property for these differences, or for this difference, I mean. How about this next example down here? So use the power property for each one of those, and then combine and use the product and quotient properties. All right, there you go. And simplify as you go along the way. Like here, you have to simplify this as 8/9, for example. All right, so any questions how this single logarithm can be written from this combination of logs down here? Well, if it turns out that you have these two numbers or expressions being equal to each other, m equals n, that means the log of m is the same as the log of n as long as the logarithms are the same base. And you can go in the vice versa direction, in the opposite direction. If log of m is the log of m, then m equals n. Now, how do you deal with logarithms of bases other than 10 or e? The reason I ask is, how could you evaluate the log base 3 of 12, for example? If you look on your calculator does not have a button for log base 3. So if you can get this expressed in terms of the natural logarithm or log base 10, then you could use your calculator to calculate log base 3 of 12. So we're going to have to do a change of base. So here's what we'll do. Let's just suppose that y is equal to log base 3 of 12. That means that 3 to the y power is equal to 12. And then you can take natural log of both sides, or you can take log base 10 of both sides. It works with whatever base, but because we like natural logarithms, we'll use the natural log. So you can take natural log of both sides, and then use the power property on the left-hand side that brings the y down, and then divide both sides by natural log 3. So natural log, log base 3 of 12. Log base 3 of 12 is the same thing as natural log of 12 over natural log of 3. Folks, please, 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 please do not cancel the natural logarithms. They're not factors here. And also don't factor the 12 as 3 times 4 and then cancel the 3's. Because I've been teaching for like 15 years now, and I can't tell you how many times that I've seen students cancel the natural logarithm operators and then cancel factors of 3 and then claim that the exact value is really equal to 4. That's not true. It's just going to be natural log of 12 over natural log of 3. And if you now go into your calculator and calculate natural log of 12 divided by natural log of 3, you can get a nice decimal approximation, 2.2619. And so go ahead and try it on your own calculator. Make sure that you can get that. So if you want to do a change of base, you just figure out what your new base is, base 10, base 2, whatever. And so if you want to go and evaluate this logarithm here, log base A, and you want to switch over to log base B, then the value of this log base A of m is, and you want to switch over to base B, just write this original logarithm as log base B of m divided the log base B of the original base. We like natural logarithms, so this would be natural log of m over natural log of a. But you could do it with log base 10 as well, because you have a log base 10 button. It just says log, L-O-G, but that really is log base 10 button on your calculator. So you could evaluate logarithms with any base out there. So you can do, logarithm base a of m is the same thing as log m over log a, or natural log of m over natural log of a. So what is log base 5 of 89? Well, if you want to use logarithms, natural logarithms, you can write that as, natural log of 89 over natural log of 5. Or if you like base 10 logarithm, you just write that as log base 10 of 89 over log base 5. Now, just as a reminder, when you just see the logarithm without the base, the implication is that it's base 10. So this is log base 10 of 89 over log base 5, which is exactly the same thing as natural log of 89 divided by natural log of 5. You get the same answer, 2.7889. Or if you wanted to evaluate log base square root of 2 of square root of 5, well, then if you want to do log base 10, you can write this as log base 10 of square root of 5 over log base 10 of square root of 2, which works out to be about 2.3219. Same thing with natural log of square root of 5 divided by natural log of square root of 2. Gets the same answer. All right, here's a summary of the properties of logarithms. Folks, be completely aware of all these, have a good working knowledge of all these properties, especially for those of you going into calculus. You will use these a lot. So burn these into your brain box. You will need these. Make sure that you do all the homework problems as well as lots of sample problems from the exercises in the textbook. The better that you are with logarithms and exponentials, the better your experience in calculus will be. All right, so that's it for all of my lectures in college algebra. I wish that we could have had a little bit more time. I know I had some turbulence with my attending training with the military, and I wasn't able to record as many lectures and get us through all the material that I had intended. But you know what? That's okay. We've covered a lot of ground, and I hope that you've learned a lot of good mathematics and that you are prepared for whatever future math classes that you end up taking. If you have not yet taken a trigonometry class and you still need an additional math class, then your next step is to take a trigonometry class or a pre-calculus class before taking calculus. Okay? All right, well, folks, take care. Good luck. I have posted homework from section 6.5, and after that, then your final exams have already been sent out to your testing centers or your proctors. All right, so good luck. Let me know if you have any questions, issues, or anything. All right, goodbye now.